Alright, so we've been studying some basic electric circuits in Physics 106, and I'd like to take a little bit of time today to look at some key terms, some definitions, and look at Ohm's law as it applies to certain example problems. Alright, so if you look in your workbook on page 142, you'll see some terms there. The first one is electric current. So I'm not going to take a lot of time in the screencast for you to write things down. So if you need to pause the video, go ahead and pause the video. But electric current is defined as the flow of electric charge, which transports energy. You can also think about this as the number of charges passing by inside the wires of a circuit in a given time. So it's symbolized by the capital letter I, and its units are amps, which is symbolized by capital A. Electrical resistance is usually a property of some kind of material in your circuit, either the wires or the light bulb, that is resisting the flow of electric current. So you can think about this as the atoms of the metal that are in the wires of the circuit. The electrons are bumping into these atoms, and that makes it more difficult for it to flow through the circuit. So certain things can affect resistance, like the material that the metal is made out of, and also the thickness of the wire that you have. There would be a higher electrical resistance for a thinner wire. Alright, so it's symbolized by the capital letter R, and the unit is a strange symbol, which is the Greek capital letter omega, and symbolizes ohms. And voltage has to do typically with the battery that we're looking at in our circuit. We'll be mostly using D-cell batteries, which are 1.5 volts, but you've probably heard of 9-volt batteries, also like car batteries typically are 12 volts. So voltage is symbolized by a capital V and has the unit of volts. Power is the rate of energy transfer. We talked about power in terms of work over a time. So similarly, we still have the same units for power, watts, and you've heard of this in terms of incandescent light bulbs. Typically you have 100-watt bulbs, 60-watt bulbs, something like that. If we know the current and the voltage in our circuit, we can calculate the power by multiplying I times V. Alright, so what does Ohm's law state? It says that the amount of current is directly proportional to voltage and inversely proportional to resistance. It's written then in symbols as I is equal to V divided by R, but more commonly you might see it written as V is equal to I times R. So I'll show you a visual representation of Ohm's law on this physics education technology simulation. If you go to that website, you'll see that actually you could either download it in Java or run it in HTML, so I'm just going to run it straight in HTML. What you can do is you have these little dials and you can adjust the voltage and the resistance and see what happens to the current in the circuit. So as you change the voltage, what it does is it adds more batteries, or it takes some of the batteries away. So you can see when you increase the number of batteries, you get a higher amount of current. Then if you adjust the resistance, you can see that when you keep the voltage constant and you have a higher amount of resistance, what's happening is these atoms inside this metal wire here, there's going to be more atoms, so there's more things for the electrons to bump into, which increases the resistance. And at the same time, that makes it harder for the current to flow in there, so the current is going down. Increased resistance, lower current when you keep the voltage constant. Alright. You can go ahead and play around with that too to better understand Ohm's law. Alright, so what is the main difference between a series circuit and a parallel circuit? Well, in a series circuit there's only one path for the electric current to flow, so you'll usually see elements in the circuit in a straight line with each other. In a parallel circuit you have multiple paths, so that means you'll typically see some point in there where there's what's called a junction, or a spot where the current has a choice. It can go through one particular wire or branch in the circuit, or it could go through this other wire. And so it will oftentimes split, and part of it will go in the top part and part of it will go in the other path on that parallel circuit. So that's the main difference. We have some other differences, so we can look at the current going through a series circuit. Typically it's the same current going through each resistor. There's only one path, so they're all flowing at the same rate. If you look at the voltage across each one, it's going to add up to the total voltage from the battery. So really it's like it's getting split. Some of the voltage is going to this resistor, some of it's going to this resistor. And if you wanted to add up and calculate the total resistance in your circuit, we can use this equation. and you just add up the resistances of each individual one in series. For parallel circuits, it's a little bit different. The current is going to split, so it's not the same current necessarily going through each one. But the voltage, each resistor has kind of an independent connection to that battery. So it has the same voltage across it as the battery voltage. And if you want to find the total resistance of that circuit, you're going to add the inverses. So 1 over the total resistance will be 1 over the first resistance plus 1 over the second resistance, etc. So I'm going to do a separate recording for the examples because those take a little bit of time to go through. So right now we're going to skip ahead to page 147 and look at bulbs of different wattages. So a general rule for bulbs of different wattage is that a higher watt bulb has a thicker filament and a lower resistance. So in that thicker filament, it's easier for the electrons to flow. It's wider, so it actually has a lower resistance, whereas a lower watt bulb has a thinner filament and a higher resistance. So if we follow those rules and we look at this first picture, which is a 40 watt bulb and a 100 watt bulb in parallel with each other, the one that's going to have the thickest filament is going to be the one that has the higher wattage. So that's going to be the 100 watt bulb. Which bulb is going to have the greatest resistance is the one with the thinner filament, which is the lower watt bulb, or the 40 watt bulb. And is the current in the 40 watt bulb less than, greater than, or the same as the current in the 100 watt bulb? And there you have to think about more current tends to follow the path of lower resistance. So in this case, that is going to be through the 100 watt bulb, since that has the thicker filament and the lower resistance. In parallel, we can think about this in terms of our houses are typically wired in parallel, so the one that's going to be brighter is going to be the 100 watt bulb. Alright, so if we look at two bulbs in series, which bulb has the thinner filament is going to be the one that is the higher resistance and lower watt bulb, or the 40 watt bulb in this case. Which one has the lower resistance is going to be the thicker filament, higher watt bulb. And in this case, both bulbs have the same current going through them because they're in series with each other. So which bulb is going to be brighter? And this is where it gets a little bit counterintuitive and a little bit tricky. It actually turns out that the 40 watt bulb is going to glow brighter when 40 watts and 100 watts are in series with each other. And that's because the 40 watt bulb has a higher resistance and a thinner filament. So that same current is getting squeezed through a smaller, thinner filament, and it actually makes it glow brighter. Alright, so this is just a recap of that. They have the current is higher through the 100 watt bulb because it has a lower resistance, so that makes it brighter when they're in parallel, but in series that current is being squeezed through a thin filament, so the 40 watt bulb is actually glowing brighter. Alright, and there's a really neat FET simulation that you can take a look at too called the Circuit Construction Kit. Unfortunately, this one doesn't work in HTML. It only works if you have Java, but I'll show you in general how this works, and that idea that different resistance bulbs will have different brightness. Alright, so I've already queued up the Java simulation. When you open it, you can see that you can grab certain circuit elements like wires and light bulbs and build your own circuit. So in this case, we're going to grab a battery and connect some wires to it. One interesting thing that I'll show you is that actually you can create what's called a short circuit if you don't connect any other circuit elements to it, like a light bulb. And what happens is that when you push play, is that it actually starts on fire because it gets really, really hot. The electrons are moving so quickly. So when you get your circuit house wiring kit, you'll want to make sure that you don't have any batteries that are shorting out or connected just by a wire with very low electrical resistance, because they'll get very hot. And I've actually had people melt through the plastic bags that they're in if they get too hot. So just be aware and try not to create a short circuit. But I'm going to reset this and show you another example of how you can use this to create a circuit. So you can grab some wire, grab a battery, maybe grab some light bulbs here too. And one thing that's neat about the light bulbs is you can actually see different connection points for the light bulb based on that activity that we did. Alright, so it has to connect on the tip and the side. Got another light bulb in here. Alright, so we've got kind of a simple series circuit here. Connect that out. And then if you push play, you can see that the light bulbs light up and you can actually see the electrons moving through the wire. And then if we change the resistance of these bulbs, we can actually alter the resistance values. So maybe this one's 10 ohms, and we change this one to be smaller, maybe like a 1 ohm resistance. Then if we play it, you can see that they're going to have different brightnesses. So the one that had the higher resistance has that smaller filament, so it's actually getting squeezed through that smaller filament and it's making it glow brighter. So we could actually, I think, maybe show the values here. Alright, so you can see that the higher resistant bulb is actually glowing brighter than the lower resistant bulb.